Hello and welcome. In this video, we will study some of the very basics of electric circuits. We will introduce the voltage source, current, power, and resistance. So let's get started. The first item that we want to talk about is the voltage. The voltage is measured in the units of volts, and volt is defined as work done per unit charge. So therefore, the units of voltage are joules per coulomb. So it's the amount of work done in moving a charge a certain distance in the presence of an external force. And this is basically the definition of the voltage. And what it means is that a voltage source actually pushes the charges around in a circuit. So it creates the current that flows in a circuit. So voltage is actually responsible for the current that is flowing in our circuit. So therefore, it is called a source. Typical sources that we use are the batteries, and in the lab, we will call them power supplies. All right. So a typical battery, for example, if you have a battery of uh, these batteries, they come in different voltages. For example, this is the positive terminal, and this one is the negative terminal, and this can be 3-volt battery, or a 9-volt battery, or a 12-volt battery. So the batteries, they come in different voltages. Now, a voltage source is represented by this symbol. This is the symbol of the voltage source or your battery, and we will use these symbols in the circuit diagrams to represent a voltage source. Now, let's say this voltage source is 3 volts. So the longer wire is called the positive terminal, and the shorter one is the negative terminal. What it means is that the positive terminal, in this case, is 3 volts higher in voltage compared to the negative terminal. So if the negative terminal voltage is 0 volts, this means the voltage on the positive terminal is 3 volts in this case. Now, for instance, let's consider this situation in which somehow I have 5 volts on the negative terminal, for example, and this battery is still a 3-volt battery. If that's the case, then we know that the voltage on the positive terminal will be 3 volts higher than the voltage on the negative terminal, so therefore I will end up with 8 volts on the positive terminal. All right, so the purpose of this symbol is to tell us that the voltage is a certain amount higher compared to the other terminal. Now, the voltage is always measured between 2 points, okay, because it's the kind of, it's like a potential energy. So we can compare it to the gravitational concept that we are very familiar with. So if I have an object on the surface of ground, if I move this object a certain height, for example, then we have done some work in moving the object, and this work is stored as a potential energy in the system. Right? So now the object has a potential energy. And now, if I let this object to drop, that potential energy can be used to do some work. So the object will fall down and it will gain kinetic energy. So the point here is that as the object moves up more and more height, it attains more and more potential energy. Voltage is very similar to that. By definition, it's the work done in moving a charge. All right, so then we can ask ourselves, like, work done in moving a charge from which point to which point, right? Now, if you look at the gravitational example, so we are doing work in moving the object against the force of gravity. So you see, the force of gravity is pulling the object back towards the ground, and we have to overcome that force to raise the object. So therefore, in applying a force and multiplying by the distance, that gives us the definition of the work, which is the potential energy in this case. Similar to that, we have that if we assume that we have an electric field, and electric field is actually force per unit charge. So this is actually force electric field is a force that a charge will experience. So if I have a charge Q located at one point and I want to move it against the electric field to another point from A to B, then in doing so, we will be doing a certain amount of work. And this work is actually, by definition, the voltage, which is the potential. So therefore, the potential is always measured between 2 points, just like the potential energy is measured between 2 points. And in this case, the reference point is the ground. So we assume that at ground, the potential energy is 0. So therefore, from that point, we can find the potential energy at any other point above the surface of the ground. Now, at this point, we will not go into more details of the electric field because it will need some more introduction and lengthy discussion. For the purpose of this video, we will just briefly describe what a voltage source is and how it is used in electric circuits. Let us consider this simple circuit in which I have a voltage source and a resistor R. Now, this voltage source, the resistance R is something that we have not defined yet, but we will study it shortly. A resistor tries to impedes the current. So we will discuss this very soon. So let us consider this circuit. We have a voltage source, and let's say that is equal to 3 volts. And it is connected in this circuit with a resistor, and this voltage source will produce a current I that will flow in the circuit. So the voltage source actually pushes the charges around, and the motion of charge is actually current. So the voltage source will produce a current in the circuit. How much the current will be, that will be determined after we have studied Ohm's law. But for now, we can say that positive charges will come out of the positive terminal and they will move around in the circuit like this. So there is a charge flow in the circuit, and this charge flow actually is the definition of current. The amount of current that comes out of the positive terminal is always the same as the amount of current that goes back to the negative terminal. Now you can see that the current is flowing from the positive terminal of the battery and it is terminating at the negative terminal of the battery. So what this means is that the current always flow from higher potential, or means from a higher voltage point to a lower voltage point. So if I have 5 volt over here, for example, and then I have, let's say, 3 volts over here, then the current will always flow from higher voltage to lower voltage. This is very similar to gravitation concept again. For example, if I have an object over here and or water, for example, if I have some water over here, it will always flow towards lower potential energy. So just like in gravity, water flows from a higher potential energy point to lower potential energy point. Similarly, in electric circuits, current will always flow from higher voltage to lower voltage. Now, let's consider current. The current is represented by the symbol I, and the units are amperes. 1 ampere is a very large current. Typical values would be milliampere or microampere or nanoampere. As you know, milli is 10 to the minus 3, micro is 10 to the minus 6, and nano is 10 to the minus 9. So these are smaller units of currents, but the current is actually measured in amperes. As we said before, the current is flow of charge. So now this means that current is equal to the amount of charge per unit time. So the amount of charge that crosses a region per unit time is called current. Therefore, the units are coulombs per second. Coulombs per second. Considering the circuit above, if we have this circuit Now that we have defined what a current is, we will say that the current is flowing in this direction with, for example, 3 volts battery attached to the circuit. And let's say this is a resistor R, and let me assume that R equals to 3 ohms. We will see very soon what is the resistance, but for now, let's say R is equal to 3 ohms. And we know that from Ohm's law, V equals to IR. This means I will be equal to V divided by R, which is 3 volts divided by 3 ohms, which is 1 ampere. So this means that if this resistor is 3 ohms, then there will be a 1 ampere current flowing in this circuit. All right. Now, the current, as we defined it, is the flow of positive charge. Positive charge moves around the circuit, and that is our current. Now, this definition is called the conventional current. And for the rest of this course, we will only consider conventional current. So this will be the direction of the current that we will always consider. Now, the actual current flow in a copper wire, which is these wires, these are made of copper because these are metal conductors. So in the conductors, the current flow is actually electronic current flow. So the electrons move around, but the electron is a negative charge. So the electronic current is actually in the opposite direction of the conventional current. Now we can use either direction, but because it is a standard to use the conventional current direction, and it is used in almost all of the textbooks, so therefore we will only consider the conventional current, and we will not solve, or we will not study the electronic current. However, it doesn't make any difference. We can do all the calculations one way or another. The results will be the same. The results are not affected. So we can either choose that we have negative charges that move in the opposite direction, or we have positive charges that move in the direction of the conventional current. The third quantity that I wanted to define today was power. Now, power is represented by P, and it is measured in watts. For now, we will see different, later on, we will see different ways of calculating power. But for now, the power is the product of voltage and current. Okay. So if I consider the units of voltage, as we said, it's work per unit charge. So therefore, the units are joules per coulomb, and the units of current are coulomb per second. So therefore, the units of power are joules per second. So you can see that power is actually work done per unit time, or you can say the amount of joules, the amount of work done in 1 second. That's the definition of power. And you can also be confident now that the product of voltage and current gives us watts, which is joules per second. So watt is the symbol that represents joules per second. All right. Now let's consider that circuit again. I have a 3-volt battery, and I have a 3 ohm resistor. And in this circuit, we will get a current that is 1 ampere. So now this battery is producing 1 ampere current. So I want to ask that how much power is this battery delivering to the circuit? So that is very easy to calculate now, that the power produced by this battery is the voltage times the current, which is 3 volts multiplied by 1 ampere. So this battery is producing 3 watts, which means it is producing 3 joules of energy every second. All right. Now, if I slightly modify the above circuit, and for example, if I say that now my resistor is larger. Instead of 3 ohms, I have 30 ohms of resistance. So the voltage source is still 3 volts. And as we said, Ohm's law, V equals to IR. So the current that is produced in the circuit will be voltage divided by the resistance, which is 3 volt divided by 30 ohms, which is now 0.1 ampere. And now you can see, as I increased the resistance in the circuit, the current has decreased, right? The current has now decreased by a factor of 10 because I have increased the resistance by a factor of 10. So, with this current now flowing through the circuit, how much power is this battery producing now? So the power again is V times I, and voltage is 3, current is 0.1. So now we are producing only 0.3 watts. So this is just to explain that the amount of power a battery will deliver is of course dependent on the load. We call it the load or the resistance that the battery is seeing. We can consider an extreme situation, for example, in which I have a battery, but I have not connected any resistor or any load. So now this kind of circuit is called an open circuit. Okay, so it's an open circuit and a current cannot flow because the resistance between these 2 points is huge, which is infinity. So therefore the current is 0. Now, how much power is this battery delivering? Which is V times I, because I is equal to 0. So therefore, this battery is producing 0 watts. So this means that if we have a battery and we do not connect it to any circuit, the battery is not doing any work, it is not producing any power, and therefore the battery can, the energy stored in the battery is not wasted or it's not used in any way. So therefore, it is not losing energy. Now, one misconception that students they have most of the time that I see is that when a students they see a power supply or a voltage source, let's say for example we have a power supply of 3 volts and the power supply says that this supply is rated at 1 ampere current, 1 ampere current. So sometimes I see students that they think that this supply will always produce 1 ampere. That's not the case. The amount of current a supply produces depends on the amount of resistance in the circuit. If you have less resistance, it will produce more current, and if you have more resistance, it will produce less current. And we have seen a few examples already. So therefore, if it's a voltage source which is represented by this symbol, it means that this source will try to maintain a constant voltage between these two terminals. The amount of current that this source produces is determined by the rest of the circuit connected to your battery or this voltage source. So therefore, the current is a variable. It can be anything, but the 1 ampere here means that this is the maximum current this supply can produce. Okay, so let's say if I do the following. If I connect a wire between the two terminals. Now, these straight lines, these are copper wires. Okay, so these are copper wires. And we use copper wires in circuits because they have very low resistance. They are very good conductor. So therefore, charges can move around very freely. And we don't lose any power in these copper wires. So we use metal for making connections or connecting different components in a circuit. So if I do this, this means I have zero resistance in the path. Then, as we said, the current is determined by this equation, which will be V divided by R, which in this case will be 3 volts divided by 0 ohms. Therefore, the current that will be produced will approach infinity. So we will have a very large amount of current flowing in this circuit, which is very dangerous. So we should never connect the two terminals of a battery because this will try to produce a very large amount of current in the circuit. Now, this battery is the one that we are considering right now. It says that this battery or this power supply can produce a maximum of 1 ampere. So therefore, the current will increase from 0 to 1 ampere, but after that, it will not be able to increase anymore, and the battery will very soon die out. Okay. But again, we should never do this because shorting a battery is dangerous. This can cause large amount of currents, which is not safe for your battery as well as for the wires because the wires can heat up and they may cause fire. The last component that we want to discuss in today's video is resistance or resistor. So a resistor is represented by the symbol R, and it's measured in ohms. So the units used are ohms. Now, a resistor can be, for example, 1 ohm or 10 ohm or 100 ohm. Resistors comes in different values, and we can have very large values of resistance and very small values of resistance as well. So the purpose of the resistor is to impede the flow of current. So what it means is that a larger resistance, if I increase the resistance, the current in the circuit will decrease. Okay, and we have seen a couple of examples earlier. So resistor actually impedes the flow of current. We can think of it, for example, as a water pipe. So let's consider two different water pipes. So for example, this is the diameter of one. So the water is flowing into the page over here. And there is another pipe with a larger diameter. And again, water is flowing into the page here. So now you can see that the larger pipe will allow more water to flow. And now in this comparison, water is actually current I, okay, for us. So a larger diameter, this pipe with a larger diameter actually means low resistance. So R is low, okay? So that means more water can flow, which means more current can flow in this type of resistor, which means it has a low resistance value. On the other hand, a pipe with a smaller diameter will allow less amount of water to flow through it. So therefore, this represents a case where the resistance is high. Okay, so if we have a high resistance, then less current and vice versa. And that's it for this video. Thank you for listening, and I will see you in the next one.